In this video, we'll explore what proteomics is, how it can be used in fisheries and conservation management, and what managers and resource users need to know to put this powerful tool into practice. The health of fish populations directly influences ecosystem stability, fisheries productivity, food security, and conservation efforts. The challenge is that stress isn't always visible. Fish experience many stressors, including rising water temperatures from climate change, declining oxygen levels, increasing freshwater salinization from road salt, contaminants and pathogens, and even handling, especially in captive reared fish or during stocking and release, can be a significant but often overlooked stressor. These are only a few examples, but what's important to remember is that stress can affect fish long before we ever see outward signs. That's where proteomics comes in, not just looking at what proteins could do, but what proteins are actually being made and functioning inside the fish. Proteins work to drive metabolism, immunity, and stress responses, and support overall fish health. While transcriptomics focuses on quantification of RNA, proteomics focuses on proteins, the products of gene transcription. So what does proteomic data actually look like? Well, similar to transcriptomics, one common output is a heat map, like the one shown here. Each row represents a protein, each column represents a different individual, and the colors show whether the proteins are more or less active. Depending on what proteomics is used for, it can allow us to quickly see patterns in how fish respond to stress, giving a comprehensive snapshot of fish health. Proteins and enzymes are ultra-sensitive to degradation, and so it is important to move very quickly once your target tissues are dissected. For proteomics, flash freezing with liquid nitrogen is the best route for keeping proteins and enzymes intact. This method preserves protein abundance, maintains post-translational modifications, and is standard practice across labs. When we combine proteomics with fishery science, the possibilities are endless. We can assess fish health at the molecular level, often before visible symptoms appear. Proteomics allows for early detection of stress from warming waters, hypoxia, or contaminants. It can help us to understand disease impacts and identify biomarkers for pathogen exposure. We can monitor pollution effects in wild fish and even evaluate resilience to climate change. But beyond stress assessment, proteomics can be used to assess food quality in fisheries management, and it can support species authentication and traceability in fishery products. Together, these tools give managers a powerful way to make proactive science-based decisions. To learn more about the use of omics in Canadian freshwater fisheries and conservation management, and for access to our database, tools, and resources, be sure to visit genfish.ca and click on the Omics Applications in Fisheries panel, or simply scan the QR code on the screen. Finally, we ask you to take a moment of your time to scan this QR code and complete our short Omics survey.